Hi everyone, this is Revathi, Assistant Professor in Information Technology from SNS College of Engineering. Today we are going to see about asymptotic notation in design and analysis of algorithm. Before that, we know about algorithm. Algorithm is a set step-by-step description of the given problem. Let us see about asymptotic notations. There are three notations to represent algorithms. First one is big O notation, omega notation, and third one is theta notation. The asymptotic notation is represented by three methods. First one is big O notation. Let us see about big O notation. Uh, Asymptotic, that means less than f of n is less than or equal to g of n, means it is represented by big O notation, and the given function f of n is greater than or equal to g of n, means it is called as omega notation. Then the asymptotic notation, that means the given function f of n is equal to g of n, means it is represented by theta notation. Let us see one by one in brief. That means f of n is equal to g of n. There exist positive constants. It is called as big O notation. F of n can be larger than n square sometimes, but I can choose some constant c and some value n0 such that for every value of n larger than n naught, that means f of n is less than c into n square. That is, for values larger than n0, f of n is never more than a constant multiplier greater than n squared. This is the graphical representation of big O notation. That means here the given function f of n is less than the some constant g int g of n value. Here the n naught represent the certain amount of time. Then next one is big O notation. That means omega of equal to a lower bound. That means f of n is equal to omega into g of n. There exists positive constant c and n naught such that 0 is less than or equal to f of n is greater than or equal to c some constant int g of n for all n is greater than or equal to n naught. That means n square equal to omega of n. Let c equal to 1, then n not equal to 2, means for all n is greater than equal to 2, n square greater than 1 into n. This is represented graphical representation of omega of g of n. Here the f of n is f of n value is greater than c into g of n. It will increase f of n values after some n naught time. Then third one is theta notation. Big O notation is not tight upper bound. In other words, n is equal to big of n squared. Theta provides a tight bound. That means f of n is equal to theta of g of n. There exists positive constant c1, c2 and n naught such that 0 is less than or equal to c1 into g of n, less than or equal to f of n, then less than or equal to c2 into g of n. That means for all n is greater than equal to n naught. This is represented the graphical representation of theta of g of n. Here the f of n value is lies between the c1 means some constant c1 into g of n, then c2 into g of n. That means c2 another constant value is multiplied by g of n. This is represented the graphical representation of asymptotic growth. Here the f of n value is in between theta and omega. Then uh, after some n naught time. Thank you.